Here I'm going to explain how to do a stoichiometry problem. Now remember, stoichiometry is just the process of converting from one thing to another, like how many tablespoons are in a cup, or how many pints of milk do I have if I have 3 gallons. It's the same thing. So in this lesson, when I refer to A, I'm referring to some sort of substance, A, and its quantity, and I'm trying to convert into a different substance, let's say B, and a new quantity. So basically, I will see how many grams I make with how many grams I use. Here is a roadmap. This roadmap, as I call it, will give us a general structure of one of the longest stoichiometry problems we'll have to do in our class. Now you will notice that in this stoichiometry problem example roadmap thing, I have some sort of ingredient that is given A, and then here is A again. But notice here in this step that this is where A turns into B. So this is kind of where the magic happens. This is where we have the way to convert from one set of ingredients A to another set of ingredients, let's say B. And then of course you can see on the right hand side here, we have B again. Note that the two steps with the letter G in it, which stands for grams, are the two steps that we refer to as the steps that need the molar mass. And of course the molar mass you can always find by looking on the periodic table. And here in the middle we have what is known as the mole ratio. And the mole ratio is where we can convert from moles A and moles B. And remember, for that step we need to look at the balanced equation, and we use the coefficients in the balanced equation to plug into these spots here. So you would use the coefficient for the given and plug it in here, and you would use the coefficient for the type of elements that we're looking for, and you would plug it in there. Note that for here in this spot we always have a 1 because that's molar mass, and in this spot we always have a 1 because that's molar mass. But notice that it is upside down. More on that in just a second. So here we have an example where I want to convert 10 grams of oxygen, now the given, to grams of H2O, which is what we want to find. So from grams of O2 to grams of H2O. And in my directions here, number 1, I say write the given, and I'm referring to writing the only number in the question that we have, which in this case would be 10 grams of O2. So that is therefore the given. Okay, so we'll work on an example later, but that's the given. Step 2, we write times line, which is pretty self-explanatory. Step 3, when I say cancel units, you can see in the example I provided that you are literally dividing grams of O2 by grams of O2, which essentially cancels it. And then we need to put something up here in order to move forward with the problem. Now I will give you 2 choices when it comes to molar mass and 1 choice when it comes to mole ratio. See if you can guess which one goes in that blank space. Molar mass can come in 1 mole A over grams A, written kind of like this, or grams B over moles B. Now keep in mind, of course, that we're still dealing with the given, so that should be 1 clue. And also, in order to cancel grams of O2, we put grams of O2 on the bottom, and this expression here happens to have grams on the bottom. So we copy the expression, but replacing A with O2, so we have grams of O2 on the bottom and 1 mole of O2 on the top. So there's my molar mass. Molar mass for O2, looking at the periodic table, is 32 grams per mole, but it is upside down. In other words, I am saying 1 mole of O2 for every 32 grams of O2, which means the same thing, and also allows us to cancel oxygen. So then what is the next step? Note that now we have another thing that we can use called the mole ratio, and that is what we're going to need to keep continuing with the problem. Down here we see that we have canceled grams of O2, and we need to keep going. Why? Well, because of the next step, which I'll tell you. But first I want to demonstrate how to use the mole ratio. So we need to cancel mole O2. And it's very important that you realize that it is at this point you cannot go to grams of H2O. It is a tempting shortcut, but it does not work because this is not molar mass. That is more of a mistake because you cannot have grams of H2O and moles of O2 next to each other on the same expression for molar mass. That's bad. So we have to go along and get rid of that. There we go. And we need to write one mole. So here, we can use the mole ratio as intended, as you see up here, whereby you're going from moles of one ingredient to moles of another ingredient, mole of O2 to mole of H2O, and that's where the conversion happens. Let me give you this opportunity to write down the next step. Do we have the units that we want? I don't know. Let's see. Down here in my problem, I'm left with, apparently, moles of H2O. And if I look up at the problem, I really want grams of H2O. So I'm not quite there yet. And if you follow the rule of canceling, you'll recognize that you have to continue by putting moles of H2O on the bottom, and looking back at the directions, which one of those expressions can I use? It looks to me like I would want to use, already used that one. Well, that's A, and A were the given ingredients, yes? Now, I want to go to ingredients B so that I can be finished with the problem. So I go back down here, and I can go ahead and write grams of H2O following my directions. And once again, that's always a 1, and all I need left is to find the molar mass of H2O from the periodic table. And now we have everything to find the answer in grams of H2O, and now we're on to step 5, answer, units, and box. Going back down to our problem here, we can see that yes, indeed, we have canceled O2, we have canceled mole O2, we have canceled H2O, and we are left with the units that we want, which are grams of H2O. That's what I mean by number 4. Do we have the units that we want? Yes, we do. 18 grams of H2O. We need not to continue. However, when we only had moles of H2O or moles of O2, we had to continue. And you'll see in other problems that are shorter, you may be able to skip some of these steps. So last but not least, we calculate our answer after filling out the mole ratio. So we are missing one thing from this problem, which we always have to be given, which is the chemical equation here. And all we need to do is look for H2O and write the coefficient in the spot that we need to put it into. So there's the 2, and I put my 2 there. This is a 1, so I need to put a 1 there. Now we have used the mole ratio. We have the molar mass of the ingredients that were given and the molar mass of the ingredients that we're trying to find in grams. So now that everything is laid out, we just use a little bit of math, and that appears to be 11.25, or you could say 11.3. No need for sig figs for this class. And we have grams of H2O. So we write the correct units. There's my answer, there are my units, and there's my box. So in the end, we can kind of see how this roadmap here looks like the problem I did, except for instead of A, I wrote oxygen, and instead of B, I wrote water, because the problem asks us to convert from grams of oxygen to grams of water. And I've satisfied that requirement by doing stoichiometry. Back to the original problem. What if I had some slightly different words here? For example, what if I said moles? How many moles of H2O can I make with? Let me go ahead and change this one too. 10 moles of O2. How does that change the problem? So how many moles of H2O can I make with 10 moles of O2? So see if you can follow along with me. How many moles of H2O can I make with 10 moles of H2O? Number 1, write the given. I times line. I cancel moles of O2 on the bottom. I look at step 3. Should I use molar mass or mole ratio? Again, I have to use the mole ratio in every problem, and also if I want to convert from one ingredient to another ingredient, let's say moles of O2, to something else, let's say moles of H2O, I need to use the mole ratio. I do not want to go to grams of H2O. There are no grams in the problem, so I don't want to make the problem harder than it is. There are no grams in the problem, so I'm not going to use molar mass. I'm going to use the mole ratio, and if I just double check here, it looks like I've canceled moles of O2, and now you are left with moles of H2O. And so now we can look again at the balanced equation. And we have the 2 for the H2O, 1 for the O2, and then you multiply across 10 times 2 divided by 1, and you essentially have 20.0. And don't forget the units that are left, moles of H2O. Don't forget the box. All right, good luck on your next problem.